We're going to look at prefixes and converting units. So most SI units have no prefixes in front of them, except kilograms for mass, which is the only one which has a prefix in front of it by default. Okay, so let's go in increasing orders of magnitude. So first of all, we've got kilo, which is lowercase k, and that's 10 to the power of 3. For example, kilometers is 1,000 meters. Okay, then we've got mega and capital M here, and that's easy to remember because mega like a million. Okay, 10 to the 6 zeros. Okay, then after that we've got giga, again capital G, 10 to the 9. And then after that, and that's a billion giga. After that we've got tera, capital T, which is 10 to the 12, which is a trillion. Okay, hopefully you notice there's a pattern here. It's going up in 10 to the power of 3s. Okay, and now let's go in the opposite direction. Let's start decreasing in size. So firstly, we've got milli, lowercase m, not to be mistaken with capital M, of course, and also not to be mistaken with meters. This is the prefix, lowercase m, milli, which is 1,000th. And then we've got micro, which is 10 to the power minus 6, and that's like given the symbol mu, the Greek letter mu. And then we've got nano, 10 to the power minus 9. Okay, then we've got pico, lowercase p 10 to the power minus 12, and then femto 10 to the power minus 15. Now pico we don't use that often, but femto we do because femtometers is the size of the nucleus of an atom. Okay, and then we've got some that don't fit the pattern. Okay, so we've got centi, which is 10 to the minus 2. For example, a centimeter is a hundredth of a meter. Okay, and then we've got deci as well, which we rarely use in physics, but more of a chemistry thing, which is a tenth of a meter. Let's practice converting some units. The radius of an atom is around 0.1 nanometers. Convert this into meters. The conversion factor for nanometers is 10 to the power minus 9. But do I multiply by 10 to the power minus 9 or do I divide by 10 to the power minus 9? Well, I don't know. Let's trial and error this. Okay, so 0.1 nanometers divided by 10 to the power minus 9. And we get 100 million meters. Okay, that's clearly absurd. That's really big when nanometers is actually a unit for something that's very small. So I've converted the wrong way here. So that would be 10 to the power of 8 meters, which is not the right answer. So let's instead multiply by 10 to the power of minus 9. And now we get a more reasonable number, which is 1 times the power of minus 10 meters, which is very small, which is what we expect because an atom is very small. The power generated by a wind turbine is 8 times the power of 5 watts. Convert this into megawatts. Okay, mega is a million, so times 10 to the power of 6. So if I take 8 times the power of 5 and the times it by 10 to the 6, I get 8 times 10 to the 11 megawatts. Okay, that's not the right way to do this. I've gone the wrong way again. Because what it should have, if I turn to megawatts, it should be a smaller number. Okay, so let's do it the other way around. It's divided by 10 to the 6, and you get 0.8 megawatts, which makes sense. Okay, so what I've done here is I do a common sense check to make sure that I've converted it the right way. A car is moving at 40 kilometers per hour. Convert this into meters per second. Okay, 40 kilometers per hour. What does that mean? That means I'm traveling 40 kilometers per 1 hour. Okay, so 40 kilometers, that's 10 to the power of 3. That's the conversion factor for that. So let's turn that into meters. So that's going to be 40,000 meters, which makes sense, like a large number of meters. Okay, and an hour, well, when you turn that into seconds, because we're going for meters per second, an hour has 60 minutes, and each 60 minute has 60 seconds. So 3,600 seconds. Okay, so now if we put that in there, like I've done there, you get 11 meters per second. A question for the volume of a box is 200 centimeters cubed. Convert this to meters cubed. Okay, 200 centimeters cubed. So centimeters is a hundredth. Okay, so it's times 10 to the power minus 2. So it's tempting to just divide that by 100 and get 2 meters cubed. However, because it's there's 3 lots of centimeters, you actually divide it by 100 3 times for each one of those centimeters. So the actual answer is going to be 2 times the power minus 4 meters cubed. The density of water is 1 gram per centimeters cubed. Convert this into kilograms per meters cubed. Okay, so 1 gram per centimeters cubed can be written like this. 1 gram divided by 1 centimeters cubed. Let's convert the grams into kilograms. So the conversion factor is 10 to the 3,000. So we're going to divide by 1,000. So that makes sense. It's going to be a tiny amount in kilograms, and then let's convert the centimeters cubed. So the conversion factor there is 100 or 100th to the -2, and we're going to have to convert each one of those centimeters into meters. So we'll have to divide it by 100 3 times. So it looks like this: 1 times is about -6 meters cubed. So that gives us 1,000 kilograms per meters cubed.